Hey there. I wanted to make certain that you guys were all good in order to complete 3.2.3 on your own at home. So you can use this tutorial to kind of get you through it. Make certain that you've got your ruler, your pencil, probably an eraser too, as well as that printed sheet from page 2, the submission form, and the 3.2.3 student response sheet. I provided links to everything that you need in there. So make certain that you have these ready and set to go, and we'll get started. Okay, we're getting started now. What I'm going to begin working with is the second page of the student submission form. When we're doing this work, you need to be consistent. So consistency is key here. So what I'm going to do, make certain that you have your metric ruler. We're going to be doing this in millimeter measurements. So you're measuring the distance in millimeters from the sample well to each fragment in the standard lane, and then recording that in this first table. So what I'm going to do, I'm going to go ahead and do these first 3, and we're going to go across. Now, the first measurement I want to go ahead and get is going to be my reference point. So distance to the reference point. So here, this first line is the reference point. Now, you could take it from any of the base of any of the wells, but remember, consistency is key. So what I'm going to do is I'm going to set my 0 up there. I want to make certain that my ruler is straight, and I'm going to measure it all the way down. Now, when I took my measurement, it stopped here at 138 millimeters. So you may have gotten 13.8 centimeters. Remember, when we're converting metric units, just simply move the decimal. So in this case, I'm going from centimeters to millimeters. I multiply it by 10 since there are 10 millimeters in each centimeter. So what I measured there is 138, and I'll go ahead and put this along the side, 138 millimeters. Now, where I'm going to be listing that is in this portion of the chart. This is the same all the way down, 138. For me, this is 138, 138. Okay. Now what I'm going to do is I'm going to find out what is the distance migrated in millimeters. So I'm going to go ahead and start over here. Oops, wrong side. And I'm going to measure. I'll start here. I'll measure from here down. And I want to make certain that my ruler, again, is straight. So I want to make certain that it's straight and it's lined up. Okay, so the very first one I'll measure is from here down. Now that one ends, it says at 35 centimeters or 3.5 centimeters, so I know that's 35 millimeters. So that one for me is 35 millimeters. Now I'm going to, and that is for this particular base pair, since I'm using a DNA marker here, these are known sizes of fragments. So these are known DNA fragments. So when I'm looking at this is 1,353 base pairs. So what I'm going to do is I will place that down in my chart. How far it migrated is going to be here. So I'll put that in as 35 millimeters. I'm going to go ahead and measure 1078. So that would be this one. The next one would be 872. So those are known fragment sizes. I'm going to go ahead and scoot it over just a bit here. Again, make certain that it's lined up correctly so that you don't wind up with a line that's like that. I'll line it up, and I'm simply going to scoot it over a bit. So now for my second one, again, I'm going from the bottom, and I'm going to go to the top. Consistency is key. So there I've got 4.12. So that would be 42 So here I've got 42. And so I'll simply write that in my chart here, 42. I'm going to scoot it over again. Make certain I have enough space there. Make certain that my ruler is straight. I'll go ahead and drop this down to the third one. So now down to the third one, I've got 4.5, 6, 7, 8. So that would be 48. That's 48 millimeters. And so I'm going to go ahead and put that there. Okay, then the only thing that you're going to do in order to get the RF is divide 35 by 138. So we'll give you time to get your calculations done, and you can pop it into the table there. Okay, so hopefully you've had enough time to go ahead and get that calculated. After dividing 35 by 138, what I wound up getting is 0.25 and 0.30 for this fragment. And for this fragment, I got 0.35. Now, where we're going to wind up using that is here. We're going to wind up creating our control. So when I'm here, what I've go ahead and done for myself, due to the size of the fragments, we already know that I don't have any fragments that are larger than 2,000 base pairs. So I'm going to be working in this area. So in order to make my life easier, what I'm going to go ahead and do, and you guys should have the opportunity to do this as well, is that I will divide that in half. So what I'm going to do is just out here, you can see that, and I'm just putting the ruler here just for demonstration purposes, so that you can see about how large each one of these blocks is. Each one of these blocks is roughly 2 centimeters in here. So this is about 2 centimeters difference. So the only thing I'm going to do is go down by about 1 centimeter, and I'll make a little mark. So I've got my little area there. I'll go down about 1 centimeter. And even half of that. So I'm making these little hash marks here. What I'm going to do is just make a line all the way across and put what that measurement is. So if this is 1,000 to 2,000 base pairs, what I'm going to wind up doing is making this about 1,500 base pairs in size. So I'll go ahead and do that. And when we come back, I'll have mine done, and hopefully you will have yours done too. Okay, so now you all can see that I have made my lines. I've gone on ahead and made them all the way across. And I put it in there that that's 1,250, 1,500, 1,750 up to 2,000 base pairs in each fragment. Okay, so now what I'm going to do is I'm going to go about graphing it. So for the first one, for fragment number 1, we know it was 1,353 base pairs in size. So that would put me somewhere in here. So around in this area. So I'll go ahead and use my fingernail as a marker there. And the RF for that one was 0.25. Well, there's 0.2, so, and that would be 0.3, 0.4, so 0.25 would put me somewhere in here. And I'm going to go up here and I will make my first mark there. The third one was 0.3, and its fragment size, excuse me, was 1,078. So that would be way down here. So there's 1,000. So maybe somewhere in here, somewhere in there. That one, the RF value was 0.30. So that's 0.3. It would be right on the line. So I'm going to place it right about here. I'm just putting dots there. My third one was 0.35. And that fragment size was 872. So with it being 872, I'm going to say that's very close to the 900 mark, and that would be 0.3. So 0.35 would be halfway in between that one and 0.4. So that puts that there. What you're going to wind up doing is creating a finished standard curve. Where we're going to use that, once we've finished our standard curve, where we're going to wind up using that is looking at the DNA. So let's take, let's go ahead and take Judy's. So for Judy's first one, we're going to go ahead and do the measurement the same way. So again, we take it from the base of the well down to the top. That's the way I'm measuring it. Just be consistent. Whatever you do, be consistent. Go down. That's where I'm measuring it to. And when I look there, that one is 45, 46. So 46 millimeters. And remember, we had to take that number divided by the reference. Once you get that RF calculation, again, you all have already, you've got the other portions of your sheets. You're going to type that information into your chart. What that will do is now allow you to compare to the calibration or the curve that you're going to wind up making here. You'll be able to find out by plugging in whatever RF you get for that into this curve, and you'll be able to see the exact size of her fragment, what the exact size is. So I'm hoping that will help you guys out. That will let you know and be able to do the comparisons very easily. Remember, you can always reach me on Remind if you get stuck. Best of luck.